Alright guys, this lesson is on volume, and I was going to go through a few examples here to help you out with your assignments. When we're trying to find volumes, again, when we're looking for volume, that's how much is inside of these three-dimensional objects. Here we're talking about prisms and cylinders. They're going to have the same formula, but you got to know what this means when we talk about base area and height. Height's the easy one, but we got to remember what the base area is. So we're going to start with these triangular prisms and move down. The formula for each of these is the same, but we do have to find out what this base area is. The base of prisms is the shape that carries all the way through the shape. And what I mean by that, it's easiest probably to see in cylinders. In cylinders, you see this circle, and that circle carries all the way through. You could, if you had a quarter that size and you needed to drop it down, it would fill that entire space as you dropped it down, if that makes sense. So that circle goes all the way through. That's why it's a base. On the triangular prisms, this one might be a little bit easier to see as well, but the triangle is the base. That's why we call it a triangular prism. But the reason why is because that triangle carries all the way through that shape. And then it's formed with rectangles on all the sides. Same thing with this one right here. We've got a triangle, and that shape carries itself all the way through. Now, these get a little bit harder when these prisms are, spun around, rotated, and you're not always sure what that base is supposed to be. But for each one of these prisms and cylinders, you need to find the area of whatever that base is. Here it is, it's a triangle. This is a triangle as well. This is a circle. This is a circle. Those are their bases. So that's the area you need to find first, and then you would just multiply it by the height, and you got the volume. So let me do I'll do a couple of these with you. Let's do number one. And number one, we're trying to find the volume of this triangular prism, so we need to find the area of this triangle. Now, what it gives us is it gives us this height here, but it doesn't give us this base. But also see that it gives us this hypotenuse over here. So if I were to draw this triangle out, it is a right triangle. I know this side is 10, this side is 26, but I actually need to figure out this side, because when I'm trying to find the area of this triangle, I need a base times height divided by 2. And I've got a right angle here, so this tells me where my base and where my height meet. But I need to find out what this side of the triangle is, because I have to multiply this side by the height and divide it by 2 to figure out what the area of the triangle is. So since I'm missing this side and it's a right triangle, I'm going to use the Pythagorean theorem. So I'm going to use 10 squared plus b squared, because I don't know what this side is going to be, so that's going to be my b, equals 26 squared. So I have my calculator right here, and I'm doing 10 squared, which is 100, plus b squared equals 26 squared, which is 676. I'm going to subtract 100 from each side, so b squared equals 576, and I got to take the square root of 576, and I get 24. So b equals 24. Perfect. So that's my missing side over here. So I've got to find the area of this triangle. So the area of a triangle is base times height divided by 2. So 24 times 10, 240, divided by 2 is 120. So we're going to 24 times 10 divided by 2 gives me, what did I just say, 120. Divided by 2. Can never be too sure. Anyway, so this is my my area of the triangle, 120 meters squared. But to find the volume, I'm going to take that area of the base. That's what I just found. I found the base area, which was 120 meters. Now I just got to times it by the height. And the height in this case is not the 10. Okay, that was actually the area, that actually helped me out finding the area of the triangle. The height of this triangular prism is actually the 17. And that would make more sense if you think about this base as the triangle getting flipped and having the base being on the bottom. And so the height is actually going to be 17 meters. So I'm going to times 120 times 17. And I get 2,040. And what units are we talking about? Well, we're talking about meters cubed, because now we're talking about volume. So cubed mean a square meter. I'm thinking of a cube, right? So this three-dimensional cube, I'm thinking of 2,040 square meter cubes is what this could be filled with. So that's why we use that notation, up to the third power, okay? So that's why we deal with volume, how much space it can fill up. Let me go on to number 3, because we're going to do a cylinder. In this case, the base is a circle. And so when I'm looking at this formula, base area, the base in this case is a circle. So I need to find my area of the circle, pi r squared, and then I have to times it by the height of this, which is the 17.5 meters. Now, this 16 millimeters, this is going to be the diameter here. Okay, it's not just pointing to this center of the circle. My diameter is going to be 16 meters, so the radius has to be 8 millimeters. So pi r squared is going to be my area of the circle, and once I find that, I will then need to times that area of the circle times by the height to get the volume. So pi times 8 squared, pi 8 squared equals 201.06, and I'll run to the hundredths place here, and we're in square meters. So that's the area of the circle. That's my base area. So then I'm going to take 201.06 and times it by the height. In this case, it's going to be that 17.5. So I'm going to take 201.06 and times it by 17.5, and I get 3,518 points, and the direction says round to the nearest tenth if necessary, so I'm going to be 0.6, and I'm in millimeters cubed. Alright, so those are our two examples for prisms and cylinders. I do have a couple other ones with pyramids and cones, and this is going to be really similar, but because pyramids and cones, because they go out to a point, they have a little bit different formula. So we're still going to do base area times the height, but then we have to divide it by 3. So that's the same formula for a pyramid or for a cone, and I'll do that in the next video.